Hey guys, so we are going to start a lab today where we are going to take a solute that is copper sulfate. Okay, so here's what this looks like. This is our bottle of copper sulfate that I would get out of the chemical storage room. And if we look inside of this, okay, this is what our copper sulfate is going to look like. It is a blue crystal. So here are some pieces that are pulled out of that bottle. So we are going to take this and we are going to dissolve it into our solvent, which in this case we're going to use water. Okay. So we are going to look at the process of dissolving. We've already started to dig into what's happening at the chemical level when things are dissolving. So our goal with this lab is to look at some of the variables that come into play and get a little experience changing variables, measuring variables as we go through this process. So what I have up on the board right now is what we're going to call our baseline data. So we are going to look at the question is how long does it take for 1 gram of copper sulfate to dissolve in 20 milliliters of water at room temperature? Okay, so you can see I've got my setup here. We're going to go through the process of getting things ready to dissolve, and then we are actually going to dissolve it and see how long it takes. So the first thing that I have to do is measure out 1 gram of copper sulfate. So I've got my balance here, okay? When we measure things on a balance, we always use a weigh boat. So we don't wanna put the material directly onto the balance, that ruins the balance. So what I'm going to do is take this little plastic weigh boat and I'm gonna go ahead and put that on the balance. Now when I measure, I don't want this weigh boat to be part of my 1 gram. I only want the copper sulfate. So on our balance, we have this T button. It means tare. So what it does is it takes whatever is currently on the balance and it pretends like it's not there. So you can see our numbers are back to 0. So now anything that I add to that is going to be the only thing that we're going to measure. Okay, so I'm going to take, this is called a scupula. It is like a scientific spoon. We use this to add solids to something else. So in this case, I'm going to transfer them from this weigh boat where I've just pulled some out of the bottle to make it a little bit easier to get to into our weigh boat that's on the balance. And I'm looking for those numbers here to hit 1.0. So taking a mass, we've got to be exact here. I don't just want something close to 1.0. I want something that is exactly 1.0. So hopefully, there it is. We can hit exactly on that number. So if that had been 1.1 or 1.2 or 1.05, we would need to make an adjustment until it was exactly 1.0. Okay. So now I've got my 1 gram of copper sulfate. The next part of our question is that says that I need 20 milliliters of water. Okay. So when we measure water, we use something called a graduated cylinder. And I've done a little legwork ahead of time and I've already set up 20 milliliters in this graduated cylinder. What I'm going to do though is I'm going to move the camera down so that you can see exactly where that measurement is. So if we were measuring liquids in a graduated cylinder as part of our lab, we would always get down to eye level, okay? And we want to look to see, is the meniscus, so that's that little indent in the middle of our water level, is it right on the line, okay? So we talked about this earlier in the year when we talked about density, but this is just a reminder for you that we always want to pay attention to the meniscus, and we're always going to use a graduated cylinder when we are measuring volume, okay? So we've got our 20 milliliters of water here. We have our 1 gram of copper sulfate. So the next thing we're going to do is get our lab set up and ready to go. Keeping in mind that we need to measure a time. The question is, how long does it take for this to dissolve? So back here behind my setup, we can see, of course it's gonna log out on me. We can see that I have a timer set up. So what I've done is I've taken my 20 milliliters of water that I had in that graduated cylinder and I put it into a beaker, okay? So beakers are really nice because they give us a little bit more room to work. We can see what's happening. We use them mostly like a cup. We're gonna hold things in them. So we don't use beakers to actually take a measurement, just to hold whatever reaction is taking place. This is what we call a stir bar, okay? So what this does is it's a magnet, and if I put it in the water that I've got, and then I set it on top of this, you can see how that magnet engages, right? It starts to move, okay? What happens is there's a magnet inside of this plate, and if I turn it on, the magnet in the plate starts moving, and it gets the stir bar to stir whatever liquid is in the container without me having to stir it. Okay, it removes some of our human error in that case because we can decide exactly how fast we want it to stir. And if I'm stirring it, I might forget or I might slow down and speed up, and that won't do it on this magnet, okay? So I'm gonna go ahead and turn on the stirring. Oh, you can see there it's starting to move. And I am gonna turn it on, so the levels are 1 to 10. I'm gonna turn it on at a 5 right now. Yep. Okay, so there it is, it's stirring at a 5. You can see it's moving pretty quickly, okay? So we're just gonna let that stir, because if you think about dissolving, right, one of the things that helps dissolve is if we stir it, okay? Imagine you're making some hot chocolate. You want that hot chocolate powder to mix in with your milk or water. You're gonna stir it to make that happen, okay? So I'm gonna have to be a little, careful here. I need to start the timer as soon as I add my 1 gram of copper sulfate, right, that I've got here. So I'm gonna add that with one hand. With the other hand, I'm gonna start the timer, and then I'll give you an up close picture so you can see exactly what's happening here. All right, ready, set, go. All right. So, if we look here, we've got a timer running in the background, and in here, we are taking and mixing this up, okay? You can see how there are those particles that are in there, those crystals, okay? They're at the bottom. We've got our stir bar going here, and over time, those are actually going to dissolve into the water. Okay, and we're gonna see how long does it take until our crystals are no longer crystals, but they have completely dissolved into the water. So what we'll do here on this video is we'll cut out some of the middle time while you're waiting, and then you'll need to see what the time on the timer says once this is all dissolved. Okay, so make sure you watch all the way to the end so that you can see what time this finishes dissolving at. All right, so there we've got it. We have, everything has completely dissolved. I'll give you a chance to go ahead and look at this. So huge change from where we started, right? You've now got a blue liquid. None of those solid crystals are left floating in there. And we can come down here and we can look at it from a side view as well. Same thing, you can see that that's clear all the way through. Okay, so our baseline data says for 1 gram of copper sulfate dissolving in 20 milliliters of water at room temperature, The time it takes is 12 minutes and 27 seconds. Okay, so the next part of this lab, then you're gonna think about what variables could you modify to make that go faster. So what are some other things that you could do to this setup to make it dissolve faster than it currently is?